Alright, so now what we want to do is practice graphing transformed versions of sine or cosine or tangent. So transform meaning that you've taken it and you've shifted it, or in this case you've vertically stretched it or shrunk it, or you've horizontally stretched it or shrunk it. You've somehow changed the amplitude and the period. Okay, so here's the things to keep in mind. The amplitude for sine or cosine, so this first one right here applies, same reasoning applies to cosine if that were, instead of sine if that were cosine. The amplitude is whatever number's in front here, so whatever A is the amplitude. To find the period, you take 360 and you divide it by that B number. Or if we were dealing with radians, most of these will be in degrees just because people tend to think more intuitively in degrees, but we would do the same thing with 2 pi because 2 pi radians is the same as 360 degrees. For tangent, the period is 180 divided by B. Tangent doesn't really have an amplitude because you might remember from the previous video, tangent just goes up and down forever. So it's not like it really has a height, although it does have a period. Okay, so our procedure is still the same. We're still going to do these 5 things, make a table of values, pick our starting point, and so on. We'll do that at least for sine and cosine. Tangent will be slightly different. Tangent, really what we want to do is find the asymptotes. Alright, so let's start by dealing with the sine. So we have y equals 2 sine times 4 theta. We want to have 5 points in our table. Okay, and then what would make this 4 theta equals 0? And the answer is 0. Okay, and then this is important, if we do this correctly, the things that we plug in to our table should end up coming out to be these 5 numbers. Why? Because on a unit circle, here's 0, here's 90, here's 180, and so on. So we want these numbers to get plugged into our function somewhere if we're doing it correctly. So we can use that as a check. Alright, the starting point is 0. Okay, the next thing is we need to have the period divided by 4 because that's what we increase by. The period in this case is not going to be 360 though, okay, because we set up here the period, okay, as it says right here, the period is 360 divided by that B number. So if you look at number 2, in this case A is equal to 2, so we know our amplitude is 2, B is equal to 4. So the period here is going to be 360 divided by 4. That's the period, which is 90 degrees. Okay, and then I don't want to confuse people here. 90 degrees is the period. Now we have to take that period and divide it by 4. So 90 divided by 4 turns out to be 22.5 degrees. So that's what we're going to increase by each time in this table. So 22.5, we increase another 22.5, we have 45. Increase that again, we have 67.5. Increase it again, we have 90. Alright, then we plug our 5 values in and we're going to graph them. So here's the important thing to keep in mind. If we chose our points correctly, if 22.5, 45, 67, if those are correct, then these numbers right here, okay, 0, 90, 180, these numbers should end up getting plugged into this function. So let's verify that. So y equals 2 times sine of 4 times 0, which is 0. Okay, the sine of 0 is equal to 0, so we have a point at 0, 0. Okay, the next point, y equals 2 times sine of 4 times 22.5. Okay, and 4 times 22.5, that actually equals 90. So we have 2 times the sine of 90, and that's a good thing. I was about to say that's a good sign, but that would be a bad pun. That's a good indicator because sine of 90, we said that was one of the values that we wanted. So the sine of 90 is 1, so this 2 times sine of 90 is 2 times 1, which is 2. So 22.5 comma 2, that's going to put us roughly right there. And the reason I know is because this is 60, this is 120, that means in between we're skipping ahead by 30 degrees each time. Alright, the next one, sine of 2 times sine of 4 times 45. 4 times 45 is 180. That's another good indicator because we said 180 was supposed to be one of our values. So sine of 180 is 0. 2 times 0 would be 0. So 45 degrees, 0 would be right here. Okay, and then the next one is going to be 2 times sine of 4 times this number is 270. And the sine of 270 is negative 1. So 2 times negative 1 would be negative 2. So we have a value at 67.5 negative 2. So maybe about right there. And then finally, we have 2 times sine of 4 times 90. 4 times 90 is 360. And that is the same as what we had up here. That's still equal to 0. So 90 degrees, 0. So now let's graph this. And let's kind of notice something here. So we have this. and then it's going to keep going, and it's going to keep going. That's enough for us to show one period. So let's verify that we did show one period. So if you look at this blue dot, we're at the middle point heading upwards. Right here, we're at another middle point heading upwards. So that is a complete period. We said the period was supposed to be 90 degrees, and you can see we're going from 0 to the other blue dot at 90. We said the amplitude should be 2, so we have a high point of 2, and we have a low point of -2. That total distance is 4, and the amplitude is half of that, which is 2. Okay, and we did get this to work. We had these degree measures being plugged in, which is what we wanted. So that's a good, I keep wanting to say that's a good sign, but again, that's a terrible math pun right there. All right, tangent is slightly different. We really, all we need for tangent is we need to know where the asymptotes are. It doesn't have an amplitude. It does have asymptotes, though. So this table of values part is not entirely necessary. Let's keep this in mind. Tangent is equal to sine over cosine. The asymptotes will occur whenever this equals 0. And on the unit circle, remember cosine is the x-coordinate. So the x-coordinate is 0. The red ones right there, the red dots are where sine equals 0. Okay, the yellow dots right there are where cosine equals 0 at 90 and at 270. So whenever 90 or 270 gets plugged in for cosine, okay, that means we're going to have an asymptote. So let's figure out when does this equal 90 and when does this equal 270. Okay, so this is going to equal 90. If we were to solve that, multiply both sides by 2, we would get 180. And this one, if we were to solve, multiply by 2, we get 540. So that means we're going to have asymptotes at 180 degrees and also at 540 degrees, which is way over here. Okay, let's see what happened to the period also here. The period, we sang up here, the period is 180 divided by b. Now your question might be, what is b right here? What is theta being multiplied by right here? And the answer is theta. You could actually write this as 1/2 times theta. So in this case, the b number is 1/2. So if we do this, if we divide 180 by 1/2, dividing by 1/2 is like multiplying by 2. So our period right here is going to be 360 degrees. And you can see that right here. If you're going from 180 to 540, that's a length of 360 degrees. That's our period. All right, so how can we get the rest? We really don't need to do a whole lot more after this. Again, the procedure is a little bit more basic than sine and cosine. We don't need 5 points in here. We really just need 3 points. And we'll get the points that occur between 180 and 540. Okay, and then what points would we want right there? We'll probably want a point where this equals 0. So when does sine of theta over 2 equals 0? Okay, and the answer is sine is 0. If you look at this point up here, sine is 0 at 0 and 180. So we want this to be 0, or we want it to be 180, whichever one falls between 180 and 540. All right, so in this case, in the first case, we would get theta is equal to 0. So that's not going to put us in our region because we want to be between 180 and 360. The second case, if we multiply both sides by 2, we get 360 degrees. So at 360 degrees, tangent, we're going to have y equals tan of 360 over 2, which is tan 180. And we know that that equals 0 because tangent is sine over cosine. Sine is 0 at 180. So we have a point right there. And that's really all you need. You could pick other points. We could pick 450 and 270, and we'll do that just for completeness sake. But you really don't have to do that. As long as you have that single point, you know how the graph it's going to go up and down. So 270 divided by 2 is 135. And if we plug that in a calculator, you end up getting -1. So we have a point at 270, -1 right there. And then this one is going to be tan of 450 divided by 2, which is tan 225, and that equals +1. That's a reference angle of 45, but in the third quadrant where tangent is positive. So we have this graph. That's what all graphs of tangent look like. So again, just to reiterate, the key things there is we found our asymptotes by setting cosine theta over 2 equal to 0. Because if we're dividing by 0, we have to figure out where is theta over 2 going to equal 0, or where will equal things that are caused cosine to be 0. And that happened to be at 180 and at 540. Why 180 and 540? Because if we look up at this unit circle up here with the yellow points, okay, these two yellow points right here, cosine equals 0 at 90 and 270. So we needed theta over 2 to equal 90 and 270, and that happens at those two numbers, at 180 and 540. And then all we really needed was where sine was 0. Sine was 0 at 360 when you plug it in right here, and then we can just connect the dots. So that's how we draw the graph of sine and tangent when they are transformed. Cosine would be the same procedure as sine.